Hi guys, I'm Miss Alicemus Logo. Today we'll be dealing with materials, underfitting and mechanism. Today we'll be exploring the characteristics, the composition and uses of ferrous materials and alloys, non-ferrous elements and non-ferrous alloys. We'll be able to identify and describe the characteristics and the composition of uses of ferrous metals and alloys. And we'll be able to explain the properties and applications of non-ferrous elements and alloys. We'll also be able to explain the composition and the use of non-ferrous alloys. We'll also be able to collect and identify samples of non-ferrous elements, alloys, and also we'll be able to provide uses for each and every sample. Ferrous metals and ferrous alloys. We're going to start by low carbon steel. We know that low carbon steel, it contains 0.1 to 0.3 percentages of carbon, ductile, and we know that it is suitable for constructions, automotive, general engineering applications. Then we're going to move to medium carbon steel. We know that medium carbon steel, it contains 0.3 to 0.6 percentages of carbon, and we know that it is strong and it is used in axles, gears, and engine components. Then we're going to move to high carbon steel, which contains 0.3 to 1.4 percentages of carbon, and we know that it is stronger and it is used in springs, high strength. To compare low carbon steel, medium carbon steel, and high carbon steel. High carbon steel, it is stronger than low carbon steel and medium carbon steel. And we know that high carbon steel, it contains more percentages of carbon than medium carbon steel and low carbon steel. We are now going to compare medium and low carbon steel. We know that medium carbon steel, it is stronger than low carbon steel, and we know that medium carbon steel, it contains more percentages of carbon than low carbon steel. If we compare the three, we know that low carbon steel, it contains the least percentages of carbon than medium and high carbon steel. And we move to cast iron. We're going to start by gray cast iron. We know that a gray cast iron, it contains 2 to 4 percentages of carbon, and it is good at vibration damping, and it is used in engine blocks, pipes, and machinery components. We're going to move to white cast iron. We know that white cast iron, it contains 2 to 4 percentages of carbon, and it is hard and it is used in wear resistant applications like brake shoes, grinding balls. If we were to compare gray cast iron and white iron, we know that white cast iron, it is harder than the gray cast iron, and we know that both of them, they contain equal percentages of carbon. Then we're gonna move to stainless steel. We know that stainless steel, it is alloyed with elements like chromium, nickel, molybdenum for corrosion resistant, which is used in kitchenware, medical equipment, and construction. We are now going to move to non-ferrous elements. Let's start by copper. We know that copper is conductive, ductile, and it is used in electrical wiring and plumbing and electronics. Then we have a tin. We know that tin, it is corrosion resistant and it is used in plating and packaging. Then we have lead. We know that lead, it is used in batteries, radiation shielding, and ammunition. Then we have zinc. We know that zinc, it is used in galvanizing and batteries as well. We have aluminium. We know that aluminium, it is lightweight, corrosion resistant, and it is used in aircraft, packaging, and construction. Now going to talk about the composition of non-ferrous alloys. We're going to start by a brass. We know that a brass, it is an alloy which is made up of copper and zinc, and we know that it is used in musical instruments and hardware. Then we have a bronze. We know that bronze, it is an alloy of copper and tin. We know that it is strong and it is used in bearings and marine hardware. Then we have phosphor bronze. We know that it is an alloy of copper, tin and phosphorus, and we know that it is strong. It is also used in bearings and electrical contacts. Then we have duralumin. We know that it is made up of aluminium, copper, magnesium, and it is strong. It is used in aircraft. We're now going to move to applications of non-ferrous components. Firstly, we have aerospace. We know that in aerospace we have elements such as aluminium, titanium, and other non-ferrous materials. They are used in aircraft and spacecraft due to strength to weight ratio and collision resistance. Then we have electronics. We know that in electronics we have copper, aluminium, and other non-ferrous materials are used in electrical components, wiring, and printed circuit boards. Then we have medical. In medical we have titanium, stainless steel, which are used in medical implants and equipment. To move to samples of non-ferrous elements and alloys, we have copper. We know that copper is used for plumbing. We have tin. We know that tin is used for plating. We have lead. We know that lead is used for batteries. We have zinc. We know that zinc is used for aluminium. Then we have brass. We know that brass it is used for musical instruments. Then we have bronze. Bronze it is for bearings. Then we also have duralumin. It is used for aircraft as well. Crucial role in various industries and applications. Understanding the characteristics, composition, and uses of different materials is essential for selecting the right material for specific application. Thank you guys for watching. Please don't forget to like, subscribe, and comment with any questions you have. Thank you. Crucial role in various industries and applications. Understanding the characteristics, composition, and uses of different materials is essential for selecting the right material for specific application. Thank you guys for watching. Please don't forget to like, subscribe, and comment with any questions you have. Thank you.